Hi everyone. Today I'm going to go over some double angle identities. So it's actually a continuation of the sum identities. So let me remind you, we had the sine, what's happening here? Okay. The sine of the sum of two angles, A and B, can be found by multiplying. Okay, so I'm going a little bit slower, so hopefully maybe you can see if you remember it. And then I switch the angle, and I didn't actually switch the angle. Sorry about that. Sine B, cosine A. Okay, and I'm not sure if I mentioned it in my other video, but sine A and B, so we're using different variables because these angles are different. But what if the angles were the same? Then let's see what happens to this formula. So if we have the same angle, okay, so an angle that can be cut in half, or an angle that can be expressed, that's why we call it a double angle, let's say 2a or 2x or 2 theta. If we simplify this, we actually have a new identity. This is called the double identity for sine. And it says that the sine of a double angle is equivalent to 2 times sine of the angle times cosine of the angle. Okay, and we're going to revisit verifying identities. So last week we did something different. Now we come back. Okay, we're going to come back to proving identities. And actually, I will say it's a very good way to learn something, to give it a break and then try it again. Okay, so that's why, and that was intentional. We took a break for looking at the functions, and now we're going to revisit proving identities. And then the other sum was the cosine of A plus B. And how do I remember this one? I remember that it's cosine first, cosine of both first. It's the opposite, and then it's the sine of both first. Okay, so that's the cosine identity. But again, if we're talking about an angle that can be cut in half, then we have the same angle, so we don't need to use B, we can use A. And what do we have here? We have the reduced, just give me a second, I need to move, there's a little thing on my screen here, okay. What do I have here? Oh, so cosine of A times the cosine of A is the cosine of A squared minus the sine of A squared. Okay, and that's the double identity for cosine. So the cosine of a double angle is actually the same as, I'll write these in a minute, the cosine of A squared minus the sine of A squared. And I'm just going to remind you that this is a difference of squares. So if ever you're doing an identity and you need to simplify, remember you can factor this way, minus the sine of A. Okay, so we're going to do a proof. We'll do two of them. Let me rewrite what I just wrote. So the sine of a double angle, see if you can remember. Actually, I'll rewrite it with x, okay, just to show you. So the identities that I'm going to use have x. I'll rewrite it with x. The sine of a double angle is 2 sine x cosine x. And the cosine of a double angle is the cosine squared minus the sine squared. Not to be confused with cosine squared plus sine squared, which is equal to 1. Okay, so let's highlight these. So we're going to look for them in our two proofs that we are doing. Okay, proof number 1. Let's see. We have 2 cosine 2x. So there we go. Already we see a double angle. The sine of 2x is equal to the cotan of x minus the tan of x. Now, I will say, so that when we first did proving or verifying identities, it was enough to only work with one side. We will, if you look at this identity here, you might think, okay, I'll do cotan and tan, because I already have sine and cosine here. But the fact that you have double angles that need to be simplified, and you have inverse and tan, we will work with both sides. Okay, so I'm going to start with the double angle side first. So the double angle, what does that give me? I have it there at the top. That gives me cosine squared minus sine squared. Double angle of 2 sine, the sine of the double angle is equal to 2 sine x cosine x. And I'm going to simplify that. And that gives me cotan x minus tan x. So we have simplified. First of all, we removed the double angle and we put in the equivalents. So now I'm going to work with the right side. So cotan is cos over sine. Tan is sine over cosine. Okay, so I'm going to rewrite this here. So just by looking at it, okay, especially if you've done a lot of practice, you might see where the denominator will come from. Okay, so how am I going to get this side, right side, to look like left side? Well, we're going to find the common denominator, and already we can see how it'll look familiar. So sine expanded by cosine, I'm going to introduce another cosine in the numerator. I'll underline it so you see that's where that's from. Cosine expanded by sine, and I'm going to introduce another sine in the denominator. Okay, and actually we're almost done. I'll just write left side here for now. We have cosine squared over sine x cos x minus sine squared over sine x cos x. And the whole point of common denominator is so we can combine our numerators. And there you have it. Left side equals right side. Okay, so that's example number 1. Of course, the beauty of the video, you can pause, you can rewind, you can go step by step. You can try to do it on your own and then move on to the second example. Okay, or whatever you choose to do. So let's do our second example. And the second example has tan squared x is equal to 1 minus the cosine of 2x, 1 plus the cosine of 2x. Okay, so it's the same idea. They're both complicated in the sense that tan can be expressed as sine squared over cosine squared. So that's where the sine and the cosine will come from. But we also have to simplify the double angles. So I'll start with that. So I'm going to put in some brackets. Cosine of 2x is the cosine squared minus the sine squared. So we have similar. We cannot cross anything out here because these are not factors. These are terms, okay? So be careful with trying to cancel out terms. Okay, so what do we have here? Let's change our signs here. So we're going to just distribute cosine squared plus sine squared. And at the bottom, nothing changed here. Okay, so what do we have here? We have, we're trying to get, okay, so let me remind you, I'll do it now. We're trying to get to sine squared over cosine squared. So that might help. Okay, that might help with our example. So at the top, we have so if we look on the left side, we want the cosine squared to disappear. So how can cosine squared disappear? Well, if you recognize this, 1 minus cosine squared is actually sine squared. So at least I have my numerator that looks like the left side, except I have one too many. And what about the bottom? So the bottom, if I look on the left, I only want cosine, so I have to get rid of sine squared. I'll remind you, you're allowed to rearrange terms. Okay, so I didn't feel like rewriting the whole thing, but you're allowed to rearrange the terms. By rearranging the terms, you have 1 minus sine squared x. So now, right, looking at what my left side should be, I at least have the correct term. I have too many of them, but I have the correct term. But we're actually almost done because we will simplify our terms in the sense that two of these terms, right, can become multiplication. Adding something to itself is the same as doubling something. And then we will see that that's where the left side equals the right side. Okay, so good luck with this video. I will send you some work. And as usual, if you have any questions, you can always contact me or join me on Wednesdays. Good luck.